Okay, well, hello everybody. Hope you are having a great day. Welcome to ENVT 163, Water Quality. We're going to get started here right away here, and I'm going to go over the course outline today and start on topic 1, so let's get into this. So first, to introduce myself here, my name is Blaine McGarry. I have a PhD from the University of Guelph, and we'll probably get to know each other a little bit better starting next week once we get a chance to see each other in person. You can see there's a photo of me, and there's my office hours. And so on office hour days, depending on whether I'm working at home or if I'm on campus, you can either drop in or give me a phone call or connect by Zoom. So let me tell you a little bit about myself. I went to the University of Guelph, and my background is biology and chemistry. I spent a lot of time looking at bacteria, and particularly the bacterial cell wall, looking at the biology of these things. So if you have lots of bacteria or virus questions, that's kind of my area of expertise. I ended up teaching this course. I'm trying to think when I got handed this course now. I bet you I've taught it about 7 times. So I've been doing water quality for quite some time. Basically 1 year, they need an instructor for this course, and they're like, hey, you know a lot about chemistry and biology, so how about you take it? And well, here I am, I'm still teaching it. So I know a lot about water now too, which is just nice. I have some pictures here of some of my bacteria to show you, and I love to talk about bacteria. So anytime you want to talk about bacteria, let me know, and we'll get into this. You can see there's my mutant babies on the right there, is what I call them. And anyway, we're going to talk about water today. Usually at this point, I'll go around the room and get everyone to tell me a little bit about themselves. Maybe something you learned last semester, or something else about you, just so I get an idea and start to get to know everybody. But I'm going to save that till next week, till we get a chance to meet in person, because it'll just be a lot better that way. And a lot easier for everybody. And I'll talk about that in a minute. So before we get too far into things, I want to talk a little bit about that and a little bit about Zoom and a little bit about the format of this class. So I was informed this morning that our classes this week will be virtual, so on Zoom, so that's Monday and Wednesday. And we're supposed to start in-person classes starting next Monday. So if this is an issue for you, you cannot be here in person due to whatever reason, whether it's quarantining or anything like that, I'll need to know, and I'll try to set up some alternative system. I'm working on trying to figure out how I can record my lectures on campus so that for anybody who's missed can get caught up later. So let me know if that's an issue. We're going to be in room S210, and so that's pretty close to my office, and I can't quite remember what the layout of that room is, but the protocols are that you have to wear a mask at all times in the college, and we do have masks to hand out to students, so everyone should be able to get 1 or 2 of those. I'm still finding out how the distribution is going to work, but you will need one to be in the building. That's mandatory. You'll have to physical distance, so that means about 6 feet to 2 meters apart. And I think with the number of people in this class, that shouldn't be an issue. And we're going to be provided with disinfectant wipes, clean our desks before and after. So hopefully you're getting the same message from all your other instructors, how this is going to work, and we can sort that out. The labs, I should say something about the labs. Here we go.
Is the lecture time to 1:50?
Pardon me?
It's a lecture to
lecture's 1 hour, so that's a typo. Thanks for asking. Yeah, I guess I made a typo there. Yeah, so the labs are going to start not next week, but the week after. They're Thursday mornings, and they'll start on the 21st. And you'll have to take a good look at the lab schedule because we have them booked in different places. So most of them are actually going to be in the environmental lab. We have 2 of them booked in the chemistry lab. So lab 1 starts in the chemistry lab, and there's 2 of them that are going to be computer labs. So I'm not sure whether they are going to be virtual online or whether Tamar is going to book an actual computer room. So we don't need to worry about that for a few weeks, but we'll stay tuned on that. So I'll come back to the instructor for the lab. The instructor is Tamar, and she's new to Kano. So hopefully you guys will give her a good welcome, and I'll be working closely with her regarding the labs. So before we get any further, I just want to talk a little bit about how the Zoom lectures are going to work and a little bit of etiquette and those kind of things. So probably most of this is relatively obvious. It's best that you're on time. That obviously works for everyone, so there's no interruptions and those kind of things. And number 2, it kind of goes along side of that. It's just being respectful to others. So in all forms, right? So if you're making comments or asking questions, we're not, harassing anybody, and we're being nice and taking things on turn. So hopefully, like I said, those are kind of, obvious type of things. Probably my experience is most students do not have their video camera on, and that is fine. But you probably should dress appropriately. What if you hit that camera button by accident, and be aware of your surroundings. There's been cases, not in my classes, thankfully, of people in the background in bathrobes or, those kind of things. And obviously your surroundings are going to impact you as well. So, if you're in class, you could be, bothering people in your house, those kind of things. So just something to consider. Dress appropriately, be aware of your surroundings. I know some of you, I think somebody just had a dog bark a minute ago. That happens, right? So, there's all sorts of things going on, I realize, in everybody's houses. So secondly, mute your microphone. And that way we're not hearing everybody's sniffles and cats and dogs and home renovators or whatever's going on. I don't mind if you want to unmute to ask a question. In fact, I like that because it helps me understand whether you understand, and just like a lecture, you're gonna ask a question. You can always use this chat function as well, and I'll answer the question when I get to it in the chat feature of Zoom. So not a problem as well. But hopefully we'll only be doing this for a short time. Again, I'm not sure what our whole situation is going to be because, of course, I may have to quarantine at some point, and if that's the case, then I'll have to teach from home or something like that. Or we don't know what kind of restrictions or whatever are going to come our way in the future. So we may have to come back to Zoom at some point. And the last one, hopefully also obvious, is be prepared to learn. So come to class, and this is your hour to think and learn about water quality, so be prepared to do so. Some of the classes, I will be doing calculations, and so, bring your calculator and do the calculation while we do it in class to see if you come up with the same numbers, and hopefully that will help you to learn as well. But once in a while, I'll be doing some notes on the board, and you'll want paper and pens to kind of follow along and take those notes. All right, so let's talk about this class. I was given this class, like I said, I think about 7 years ago, and it was a bit of a mess. So I was asked to kind of develop it and around water quality, and there's a whole bunch of things that are going to go into water quality, right? We're going to talk about kind of the usual things, a little bit of chemistry, a little bit of biology. We're going to talk about water treatment. We're going to talk about water resources in Alberta, and those are all the kind of things we're going to talk about. And I think I have a topics list here in a moment. I'll get to that. Something I want you to think about as you are going through this course is think about how this is relevant to you, because you're probably going to find there's a lot of areas of water that are very relevant to you. It has to do with our health, has to do with our economy, and many other things. So these are the learning outcomes. So obviously to learn about water quality, we're going to talk about environmental issues. We're going to talk a lot about water treatment kind of at the back end of the course. So we'll probably won't get till about March. And that's going to be a big part of the last part of the course. And you can see, obviously we have a lab. And so in the lab, you're going to learn a whole bunch of different types of things, using different types of equipment, different types of analysis, and also you're going to get practice writing various lab reports. So we'll get to that eventually. Since labs aren't starting right away, we're only going to talk about the labs a little bit today. So hopefully everyone has been to Moodle, and that's where you're going to find all the course resources. And so course outline, PowerPoints, some of the units I have study questions, so you can check those out. And sometimes I'll post additional readings for the course, because there is no textbook for the course. So everyone's thinking, yay, no textbook, which is good. Most of the readings are going to come directly from the PowerPoints. Once in a while, I will refer you to additional sources that I expect you to take a look at to supplement the course. For the most part, this is a relatively, how shall I say it? It's not a heavy course. You only have 2 hours of lecture a week instead of 3. And the labs are not like, they rarely run 3 hours. So, hopefully this course will be a little lighter than, say, Chem 101 and a little bit more enjoyable. I think most people really enjoy this course for the labs because the labs are really hands-on, and every week we're doing something different. And so they're lots of fun. So the setup of this course is I have 4 tests. I don't have the dates for the tests yet. They're approximately every 3 weeks. So you're not going to have a test next week, but possibly the week after. I just have to see where we get roughly next Monday and see how much material we've actually covered. Lab reports are worth 35%. So you have to take a look at the lab schedule to see when the lab reports are due, and I'll come up to that in a minute. And then we have a final exam which is worth 25%. So I'm calling these tests, by the way. They're not really midterms. They're not really quizzes. I don't want to use the word quiz because their quiz is kind of short and insignificant. These are 10% each, so they're significant enough, but they're just not quite a midterm. So usually I give people about 25 minutes, so kind of half of a midterm. You can kind of think of each test as a half midterm. And like I said, we do one about every 3 weeks. So these are the topics we're going to cover. So like I said, a lot of information around water properties and chemistry and infectious disease. The middle part of the course, we're talking about water quality standards, water use, distribution, things like that. In the last part of the course, we're talking about water processing, so water treatment. So we've got drinking water treatment, and we also have wastewater treatment. And then at the very end, we are squeezing in a small unit on air quality. You don't take any air quality courses in environmental programming until your 3rd year. So we figured we could put a little bit into this course because it fits just fine. And we're not at the stage yet where we have any air quality labs. We're kind of working on that. But what we might do is put on a demo at some point during the semester. So hopefully that will work out, and we'll get a chance for you to look at some of the equipment used to measure air quality this semester as well. So here is the lab schedule. So like I said, we're going to start off in January 21st, we're going to be in the chem lab. And then you can see we've got a bunch in the environmental lab, and some are going to be computer labs. So we have a variety of exercises to do. So do take a look at the lab schedule, particularly around the due dates. In many cases, so you can see, for example, the first lab, we run it on January 21st, and the report is due 1 week later. Same thing with the second lab. The second lab actually runs into the 3rd week. So you can see lab 2 here, photosynthesis, dissolved oxygen, and biochemical oxygen demand. You don't get the results until February 4th. So the report itself is due 1 week later. Lab 3 on February 4th is a big one. That's the most important lab of the semester. And for that one, you're writing a full formal report. So that's going to be a lot more involved. And so you're actually going to get 2 weeks to write that. And I think actually looking from the schedule, because of reading week, I'm not going to have you hand it in during reading week. You actually get an extra week. So lucky you to do this report. The second week of this, there is actually no lab scheduled. And what you're going to do is have a consultation with Tamar. And what that means is you're going to show her some of the work that you've done, and she's going to give you some tips on report writing. So yeah, we'll go through the semester on this. I don't know if we're going to be able to do a field trip on this course yet or not. Normally we do 2 field trips, one to the drinking water plant, one to the wastewater plant. At the moment, they've said they're not doing field trips, but I'm going to contact them in March and see whether things have turned around or not. So that would be wonderful if we could do that, but considering the pandemic and all that, I don't blame them, but it would be very nice if we could do that. They're very good field trips. So there's Tamar's information. It's in the course outline, and you'll get a chance to meet her in your first lab. And so, like I said, that's in the chemistry lab. She does have office hours most days at 1 o'clock. I recommend emailing her because I know she works sometimes on campus and sometimes at home. And I'm not really aware of what her schedule is, so maybe she'll make that clear to you when you meet her in the lab. So just a reminder for the lab, everybody here has already been through a semester or 2, so you should have your WHMIS training. So I'm not even asking you for your WHMIS certificate, but if you've been around a while and you don't have that, please let me know. I'm actually going to check your names this week to make sure you all have the training. You're going to need your lab coat. Notice it's in a big Ziploc bag for the chemistry lab. In the chemistry lab, you are going to need lab goggles. I'm not sure whether you needed them last semester on your own, but I believe this year we're asking everybody to provide their own goggles because of the pandemic. We don't want to be sharing goggles or having anybody share goggles. So if you need some, I think the bookstore actually has some now. If not, you can get all sorts of different types of goggles at, I think there's a place on Riddell Street, a safety store. I can't remember the name of it. Or even Canadian Tire, Walmart might have goggles. And we're not talking about glasses, we're talking about goggles that prevent splashes from going in behind your eyes. Some are going to be a lot more comfortable than others, but do make sure you have your own for that day. We do have some extra ones, but we're going to have to clean them and disinfect them, and I'm not even sure if I'm really supposed to be handing them out. So I'd rather you come with your own goggles. The lab manual is printed, as far as I know, and it's in the Keanu bookstore. So make sure you get your order into the Keanu bookstore as soon as possible. I've heard today that they are very slow. So if you put in your order today, it would be nice if you get it tomorrow, but I don't think that's going to be the case. So get that in right away. If we're having issues with people getting the lab manual, please let me know. And you know, the first lab, we can just I can just email you an electronic version for you to print off at home or something like that. So one more reminder about the labs. You need your lab coat. You're not going to bring any food or drink in there. But one of the issues that we have, and we don't usually have this issue as much in the winter, but you do need to be fully covered down in the foot area. So flip-flops, proper shoes, and you'll also need to have socks and pants that cover your ankles. So make sure you wear proper socks or proper pants, because if not, we have to turn you away and you have to go find some. And that's never fun, particularly in the middle of a pandemic. Okay, a couple other things about the course outline. I went to this seminar about successful students a while ago, and they gave this list, and this is apparently what successful students do. So it's a big long list here, and you can see I've actually highlighted some of these things that I think are important for this course. So obviously for this course, you are doing lab reports and tests. So test preparation is going to be important. And to prepare yourself for tests in this course, every test will be 3 pages, and 1 full page up to 1.5 pages will be some sort of problem solving. So it's important that you do the problems and that you practice them and understand how to do the math. It is not difficult math, but a little bit of practice can go a long way. Other test preparation is just going over the notes and making sure that you do understand the material. So if you do have any questions with that, let me know. If you do really poorly on test 1, that's okay. There's 3 more. Each test is not worth a massive amount of marks, but hopefully it gives you a chance to improve if you do poorly on the first test. Like I said before, I don't think this course is extremely difficult like chemistry. It's a little bit more straightforward, but at the same time, you will need to study and you will need to prepare for your tests. So one more thing, just consider what you're doing, whether you're learning online or whether you're in class, you know, how you're using your technology. I know lots of people have, you know, what shall we call it, addictions to, you know, things like Twitter or Snapchat or Instagram. These are not bad things, but if you're checking them many, many times an hour, you may have issues, right? If you're doing this while you're driving, that would be called impaired driving. And my concern, of course, is about impaired learning. You know, if you're multitasking or other things, you know, just think about how it may be affecting your learning. Because, of course, I want you to listen to my class because I think my class is important and I would like you to learn lots. I believe everyone is familiar with the grading system at Kano. So this is the conversion between the different grades and the letter grades and the percent grades. So I always try to highlight this here, right? C minus. So C minus is probably the minimum you should go for because you're going to need that if your course, and this course is a prerequisite for others, you're going to need a C minus to take any course after this. I think with the diploma you can graduate with 1 or 2 Ds as long as they're not prerequisites for something else. So I'm hoping people are not aiming for a C minus, but something a lot better. And I think all of you certainly can do a lot better. So hopefully we're going to have some great grades in this course. So a few more things. Please come to class. All the labs are mandatory, so if you can't make one, you know, we will excuse you for, you know, good reason. If you are ill or have other compassionate reasons, we need to know. But you will be responsible for all the lab work. Make sure you ask questions, use your instructors. We can certainly help you with your studies. I think this is the last slide I have of my introduction here, and you can see this is Beatrice, the biologist, and she says, sometimes I drink a glass of water, and I stop to think about the millions of molecules have been on Earth for billions of years and all the things they've done in places they've been. So kind of interesting. A little thoughtful. I'll try to share some cartoons with you. That one's not funny. That one's more thoughtful than anything else. But anyway, so let me see where we are with time. We are at 1:24, so that's about right. Please take a look at the full course outline. I am sure that I have forgotten a few things, but I think I've covered all the important things. And like I said, I will sorry, I'm just trying to figure out something on Zoom here. There we go. I will have dates for the quizzes or the tests announced a minimum of 1 week in advance. And so, like I said, it kind of depends on how quickly we progress through the material when the test will be. And so we'll have more information on that soon. So I'm going to switch now, and we're going to start on topic 1. And let's see here. I just lost my Zoom link here. So just give me a moment. I got to figure out how to share this. There we go. And I think what I'll do is just turn my video off. It takes up too much space on my screen. Besides, you don't need to see lots of my face. You'll see lots of it in person, hopefully. So topic 1 is kind of an introduction. We're going to talk about water in general. We're going to talk about Alberta water resources. We're going to talk a little bit about water's properties, which kind of segues into the next unit, which is all water chemistry. We're not going to cover it all today. Today is going to be a little bit of introduction. Hopefully some of it is review for you. And I know in Neil's courses, you certainly cover you know, some of the information around things like groundwater and general geology and things like that. And so, which is good because that's not my area. I'm more into the chemistry and stuff. And so, you know, it's good that we can complement each other. So I'm going to try to have, in my slides, I'm going to have lots of links. Some of the links will be found as a reference page right at the very front. These are probably the most important ones if you're looking for more information to go to. And then there'll be lots of links on my slides too if you're looking for more information about that particular topic. I do want you to take a look at this one here. So I've put this publication on the middle page, and I'm letting you know right now this is it's about 60 pages, and I would like you to read it for test 1. So this is what you can do this week because you have no lab. So Thursday morning, with all that extra time on your hands, I want you to go over this publication. Not everything is important for test 1. It talks a lot about, for example, it talks about the Calgary region and whatnot, but particularly focusing on Alberta water resources and particularly about the Athabasca River Basin. That's kind of the information that I think is most essential to what you need for test 1. I'm covering it in the lecture too, but like I said, this is I consider this an assigned reading for this topic, and that will be something that I'm going to look at as I write test 1 and pull a few questions out of that. So here we are. There's planet Earth, and you may have heard of this thing called the Goldilocks principle. And remember the story of Goldilocks. Goldilocks is tasting some porridge, and when she's tasting her porridge, well, it turns out that one bowl of porridge is too hot. And if you think about this with Earth or Venus, Venus is too hot. It has water. The water is mostly vapor. Another bowl of porridge was too cold. And that's kind of like Mars, where the water is all ice. And Earth is just right. We have water in all the states. We have liquid, vapor, and ice, and the porridge is just right. So this is Earth. It's a good place to live. And we have lots of water. And of course, water is essential for many of the things we do. In particular, it is essential for life. And this is something I'm interested in because I consider myself a biologist, and of course, you know, I think life is a very important thing. So Fort McMurray has got to be, you know, somewhere maybe just below that cloud is my guess. It's a little hard to tell exactly where that is with all the cloud cover. And so we'll be talking a little bit about the water resources in Alberta and around Fort McMurray.
Yeah, my area would be like PEI and that, like east where I'm from.
Mm-hmm.
And that's surrounded by water.
Oh yeah, I know. I mean, Canada is a very water-rich country, right? And I'll show you some maps on that in a minute, and I've got some numbers. It's just sometimes it's amazing to think how much water Canada has. We're very lucky. Mm-hmm. I found this is a really cool image. This shows if you took all the water from Earth and put it into a ball, that's about how big it would be compared to the size of the Earth. So a diameter of about 1,400 kilometers and a very large volume. So that's, what is that, 1.4 billion cubic kilometers. I can't even imagine that kind of number. It looks small, but if you think about the thickness of sort of the depths of the oceans compared to the actual size of the Earth, it's actually pretty skinny. You're probably wondering what those other little dots are. So that's the fresh water. So fresh water, about 3%, and by fresh water, you know, we mean not salty. So you can see the definition there. It says as little dissolved salts in there. So things that we can drink and be happy with. Notice there's another little guy there, another little dot. And this is the amount that is easily accessible to humans out of all the fresh water. So that's about 0.01%. So, you know, this makes water, you know, a resource. And, you know, we have to, you know, it is very abundant, but we do have to be careful. And in some places in the world, we have to, of course, you know, be more careful because, you know, there's only so much of it. It is limited. I have some actual numbers for you here. So if you take a look up here at the top, the two biggest sources of water on the planet, they are the oceans, so 96.5%. And the second one is frozen. So we're talking about ice caps and glaciers and things like that. So that's 98 point something % of our water is inaccessible for that reasons. I think I have all the yellow there, that's the fresh water, and much of it is not accessible. So I can't remember what that number was. I had 0.01% or something like that, which is a very, very small amount. I know I have a graph or two to show you as well that kind of makes this out. But if you take a look, there's water in places you may not necessarily have thought about. The atmosphere has water in it, of course, in clouds, and a very small percentage of water is found in biological life, right? So you have water in your body, there's water in the trees, and so on. And it's actually a very, very small percentage of the total amount of water out there. So this is from the same source, and they're trying to show you in a graphical way, right? So if you take a look at this first graph, that's all the water, and then this little slim thing here at the top, that's the fresh water, and that's what they've expanded out to make that second bar graph. And they're showing that most of the fresh water is in glacier and ice caps. A big chunk of it is in groundwater, and a very, very small percentage of groundwater is accessible to humans. And I think it's something like 0.01%. So most of that groundwater is not accessible to humans. So this leaves us mostly with that surface water, this 1.2% up here, of which I don't know why they have surface water as ground ice and permafrost. Okay, I guess they're saying that's somewhat accessible. And then we've got lakes and rivers and things like that, which is the water that's accessible to us. So a very slim fraction of all that. I think I have some definitions here for you. You may have heard of these terms. When we're talking about ecosystems, sometimes we talk about things being lentic or lotic. I don't know if you've heard those terms before. Probably David Smith talks about them. I don't know, actually might be in the second year course, I'm not sure. But lentic means still water. So we're talking about lakes and ponds. And lotic means flowing water. And sometimes we do talk about other types of water in natural sources, groundwater being the third one that I would consider, kind of the three categories of water used by humans. Primarily, right? So sitting water, lakes and ponds, and I guess you'd say reservoirs as well. There are a lot of man-made lakes and reservoirs out there, particularly in southern Alberta. Lotic is rivers, so Fort McMurray has a big river where we get our water, and groundwater. Some people use groundwater. Not as much in Alberta, but if you live on a farm or some rural area, you may have a well. And so that's a small percentage of Alberta's water, but much higher percentage in the United States of people using groundwater. There's just another graphical image of that, where you can see a tiny wedge of the water is usable by humans, and a tiny wedge of that is, of course, lakes and rivers. So something we're kind of going to hint on and touch on a little bit here and there is water scarcity. It's not a huge issue in Canada. Like I said, we're a very water-rich country. But what I mean by water scarcity is where people don't have enough of it, whether it's for their own use or for the use of their crops or their animals or other things, right? Of course, a lot of industries rely on water as well. You can think of, this is kind of the big question. There's so much water out there. How can there be scarcity? Well, you probably know there's deserts. You can think of scarcity for two reasons, right? There's not enough fresh water nearby. So in that case, this would be drier areas of the planet. And there's a lot of places where water scarcity is due to economic reasons. So for example, in many countries, people are not treating water enough. And so they get sick. And for example, if anyone here has ever been to Mexico, you probably know the very first thing they tell you, you get off the plane, and they say, do not drink the tap water. They don't treat their water well enough in Mexico, so many people get sick from it. And that is due to economic reasons. And they're doing better. Mexico is starting to put in more water treatment plants and starting to deal with it, but it's going to take them decades to really catch up to where we are in Canada. Of course, something you'll probably hear a lot in many of your courses is that climate change, of course, affects water supplies and those kind of things around the globe. You can see this is a little graph from Natural Resources Canada that is touching on some of those issues about glaciers melting at different rates, dryness, which can cause forest fires, and of course supplies for agriculture and so on. So lastly, I just want to show you this here. This is a publication I was reading a couple years ago talking about water scarcity around the globe. And they were talking about hydropolitical interactions. So what do they mean by that? They mean that, you know, when there's not the supply of water, this can lead to a lot of tension. You know, people are fighting over it. People are disagreeing on who gets how much and those kind of things. And we don't see that a lot in Canada. But in other parts of the world, these are becoming great concerns. In the western United States, the Colorado River, that's the one that goes through the Grand Canyon. That one goes through, I'm not sure how many states, 4 or 5 states. And there's a huge amount of disagreements on, you know, how much water each person, each state can have. And of course, that's a pretty dry region. And it's amazing they're taking as much water out as they are. And so that may change in the future because the water is going to get more scarce. So you can see this is just another chart saying that, you know, if you look at the places in the world that don't have safe water, so it's the one on the left I'm looking at, it says places in the world without access to safe water. The one on the right is sanitation. So you can see the big areas are Asia and Africa, and then followed by Latin America and the Caribbean. And, you know, North America, we're doing quite well, which is, you know, makes me happy. It makes me happy I'm in Canada, but of course, these are issues that are going to be reoccurring in the world for many years to come. So some of these threats to water supply, and most of these things are probably pretty obvious, right? Human expansion, so more people, agriculture expanding, cities expanding, those kind of things, which leads to all sorts of things such as more pollution, et cetera, et cetera. Problems with not having enough water. This affects our health directly. And so we are going to talk about water and health when we get to water biology. Hunger, not enough water, not enough crops. And all these things lead to shortages in things like education and poverty and whatnot, and have huge effects on the world. So a little bit more on some of these things later. So let's talk about Canada. Like I said, Canada is a water-rich country. There are some areas, though, where we do withdraw a lot of water and do have a little bit of water scarcity. You take a look in Canada, Eastern Canada, we have this area here. So around Toronto and the neighboring cities, there's a lot of people there. So we withdraw a lot of water. And so that area has to be managed very, very tightly. That is a relatively water-rich area of the world because of the Great Lakes. If you go west, you know, we're looking at Calgary and southern Alberta and southern other parts of the southern prairies, and we have a lot of agriculture there. And unfortunately for that part of Canada, there's also a lot less rainfall compared to many other parts of Canada. So this is something that has to be managed very carefully, and you know, if we want to sustain our agriculture in those particular areas of the country. So I think I have a bunch of maps in one of the later units that talk about this in agriculture in general.
There's some areas that just have no data.
Yeah, well, and some of the data is old. You'll see on my slides I have a lot of years, and sometimes the data will be like 2006 or something like that. And of course, you know, a lot has changed in 15 years, right? You know, in terms of water management and all sorts of other things. Found this cool map. It's kind of showing the lakes and rivers of Canada, and you can see there's concentrations in various places. And I kind of like maps; they're pretty cool. And wish I knew a little bit more about the geology of these things. But my understanding is a lot of those lakes that you're seeing kind of in this part of Canada, that's kind of Canadian Shield. So you're looking at many of those lakes carved out by glaciers in various ice ages. That's apparently how much water we actually have in Canada. It's a big number. That should be, it's 11–12% of the total area of Canada. That's pretty impressive. Even more impressive is this number here. I just read this morning, that apparently Canada has 20% of the world's fresh water. So lucky us, that's good. So here's the question, where does all the fresh water come from? And so just think a little bit for a second there, and you probably know the answer. The answer is the water cycle. So the water cycle Sometimes it is also called the hydrological cycle. So hydro, this word here, hydro, means water. So anytime you see hydro, it means water, something to do with water anyway, like hydroelectric power is, where we're making electricity using water, for example, right? I'm just going to call it the water cycle. Hydrologic is just a lot more syllables, but you might see both. You may also see this term here, hydrology. And hydrology means the study of the movement of water and distribution. So both naturally, and it can also mean through pipes and through engineered structures as well. So hopefully people remember the water cycle. I'm going to review it kind of quickly here. You remember the 6 processes that make up the water cycle? Most people can remember about 4, has been my experience. So here they are. Evaporation, condensation, precipitation, surface runoff, infiltration, transpiration. So I have a really nice picture here to show you those stages. So here is the evaporation, condensation, precipitation, surface runoff, infiltration, and transpiration. This is from United States government, I think it's the Geological Survey. Nice website. You can see they have a couple other things in there that are kind of related, like water storage in oceans and things like that. But I have a slide for each of these, so I just want to talk about them briefly. So first one is evaporation. And this is where water is going from liquid to gas form. And this is kind of the main way that we get fresh water in a sense, right? We have massive amounts of evaporation on the oceans, and that water is going to eventually end up on the land. So we're thankful for evaporation. This is, of course, powered by the sun. That's the primary source of heat energy on the planet. And so we're very thankful for evaporation. I guess I just said that, didn't I? I just answered that question. Where does large-scale evaporation occur? The answer is the oceans. And thanks for that, right? 2 is condensation. So that is where the water vapor is starting to turn into liquid. And of course, this is where we get clouds and eventually precipitation. So clouds, I don't know a lot about clouds, to be honest with you on that. But my understanding is that's where the water is starting to turn into vapor, and often it's collecting around dust particles, and it kind of makes it look white. And eventually when those
It's actually evaporated water from the sun.
well, eventually when the droplets get big enough, the gravity allows them to fall, right?
Yep.
Yeah, so there's lots of different types of clouds, of course. I remember learning about them in grade 3. So it was a long time ago for me.
Blaine, I remember that I learned that in clouds, like water is it's like the only time where water is in all 3 states, solid, liquid, and gas.
Oh, really? That's kind of cool. Yeah, I think I remember learning about something about that once a long time ago. And I know it has something to do with dust particles too, in terms of the water collecting around the dust particles. Because I know I was reading about somewhere in the States, they were experimenting with having these little airplanes, fly up in the sky and spreading dust particles that would allow the water to collect and make it rain on the crops. And I don't know how the experiment went, but thought it was kind of an interesting way to do it. Precipitation, of course. Remember, I must have been about grade 7 or 8. Our teacher asking us to list, I think it was 10 types of precipitation, and nobody could come up with 10. But of course, there's a bunch of different types of precipitation. That's where it's falling down. I found this little graphic on the internet. These are kind of the main ones. I think people will sometimes classify some of these things differently, like there's rain and ice rain and sleet having different classifications. But, in my mind, it doesn't matter too much. It's all water falling to the ground. It's either solid or liquid or somewhere in between usually. Some people will include fog as a form of precipitation. I've seen that on a list as well. And so hopefully, we don't get too much more snow. I'm running out of places to put it this year, although I wouldn't mind a little bit more snow for skiing. But my driveway, I have nowhere else to put it. It's kind of crazy this year. So a couple of things about precipitation, right? You can see I have this word here, and it says here, as air rises, water cools adiabatically. So I think I have a definition on the slide here. So it cools by expansion rather than losing heat to its surroundings, and until the clouds form anyway. And eventually droplets form, and when they get to about 100 micrometers, we're looking at them usually falling. So if you don't know what 100 micrometers is, that's a good one to know what a micrometer is. Maybe I'll write that down. 1 micrometer, so that little thing here that looks like a U is actually a mu. So a mu that starts with an M is a Greek letter, and it's part of our metric system, and it means 1/1,000th, right? So if you think about this, 1/1,000th is 10 to the minus 6 meters. 1 micrometer is also 1,000th of a millimeter. So that's 0.001 millimeters. Just for context, that's about the size of E. coli. So if you're interested in bacteria, that's about what you're looking at. It's too small for the eye to see, but we can see those things under a microscope, of course. Oh, I do have the conversion on the slide right there, so imagine that. Number 4 is surface runoff. So this is basically water flowing on the land after it falls to the land from precipitating. And of course, lots of people are interested in this because, of course, this is how nutrients are distributed and also how erosion occurs. And depending on where you are in the world, this can be a huge concern or not much of a concern. I know I was reading about erosion. I guess it wasn't necessarily erosion, but I was reading about in Manitoba. It's a very flat place, and they have flooding every once in a while. And it was talking about the flooding and how that distributes fertilizer, and the fertilizer gets into the rivers and causes algal blooms. So we'll talk about algal blooms soon.
Well, did you know one thing, Manitoba? Like sometimes, like they can get you can get thunderstorms where you can get dropped over 4 inches of rain within like half an hour to an hour.
Well, I'll tell you, I don't know what year that was. I'm guessing about 4 or 5 years ago. I drove through in the summer, and it was incredible to see entire fields just full of water. It looked like there were oceans. It was amazing that year. And of course, there was a little bit even on the highway. Thankfully, it wasn't too deep to drive through, but when it gets up that high, you start to worry.
We had
crap somewhere.
The year after I moved here, when my parents and I moved here, like they had so much snow on PEI that like it was so much snow in 2015 that we were talking about at least 7 or 8 meters high of snow all the way up to people's roofs, and it took by June that year there was still some snow patches of snow left on the.
Yeah, I've seen that a couple of times in Ontario. It's really incredible, isn't it?
Yeah,
so, I just want to wrap this up for today. Just take 1 more minute of your time. Just finish off the water cycle here. There's infiltration. We'll come back and talk about infiltration a little bit more when we talk about groundwater. That, of course, means the water getting into the soils or porous rocks. And like I said, we'll talk a little bit more about groundwater next day. And then number 6 is transpiration. So that is basically plants sweating. So plants, of course, take up water through their roots, and the water goes up to their leaves. A very small percentage of that water is used for photosynthesis, and much of it is lost through the pores in the leaves. And a lot of people think, oh, that doesn't sound like very significant, but this is about 10% of the water in the atmosphere. So it is huge. And of course, this is why rainforests, of course, have a lot of their ecology, because of all the plants in the rainforest are transferring so much. It causes daily rains in many parts of the world. So I think that is where I'm going to stop for today. We're going to talk about this next day a little bit, of course, how humans are intervening in the water cycle, where we're taking water out, and we're putting it back in, and those kind of things. So we're out of time. So thanks for coming out today. I will see you on Wednesday on Zoom, and next Monday in person. So have a great afternoon and take care.
Thank you.
Thanks.